Hey guys, welcome back. And this is Nagaraj SK, lecturer of Computer Science and Engineering Department, Jain Polytechnic, Belagavi. So, from the third unit, brute force approach and exhaustive search approach, we'll move to the lecture number 26 and 27. So, here I'm going to cover the exhaustive search and traveling salesman problem. So, what exactly the exhaustive search and what are the types of exhaustive search problems, exhaustive search approach? So for what kind of problems we are applying this exhaustive search algorithm for the given problems, what kind of problems we are solving with the help of this exhaustive search approach. So these are the two things I'm going to cover here, that is exhaustive search approach, and we can solve traveling salesman problems, that is TSP, with the help of this exhaustive search algorithm. So what exactly the exhaustive search is, right? Exhaustive search is a method in which solution is obtained by searching each element of given problem. So exhaustive search makes use of straightforward brute force approach, and we will now understand the concept of exhaustive search with the help of three important problems, that is traveling salesman problem, knapsack problem, and the assignment problem. So at the very first, we'll move to this traveling salesman problem. So traveling salesman problem is a famous problem in the graph theory. So it can be stated as like as follows: consider that there are n cities, and traveling salesman has to visit each city exactly once and has to return to the city from where he started. So, to model this problem, weighted graph can be used, and the vertices of such graph represent cities, and the edge weight specifies the distance between the cities. So this problem can also be stated as finding shortest Hamiltonian circuit of a graph, and the shortest Hamiltonian circuit is a cycle in the given graph such that all the vertices of the graph can be visited only once, and the tour obtained in such a way has shortest distance. So we'll move to the next slide, that is here Hamiltonian circuit, a sequence of n plus 1 adjacent vertices, that is Vi 0 to Vi n minus 1, right? So how can we solve this kind of problems using exhaustive search, that is traveling salesman problem? So first what we have to do here, get all tours by generating all permutations of n minus 1 intermediate cities, then compute the tour lengths and find the shortest among them. So here we have an example, that is graph we have, that is it is having four cities, four vertices, that is a b c d, consider it as cities, four cities, and the distance from a city to c city is 5, distance from a to b is 2, a to d is 8. Similarly, the distances all other cities to all other cities, we have some distances like b to c is 8, b to d is 3, b to a is 2, and d to a is 7, c to d is 1, then d to b is 3, something like that we have. So we have to traverse here, we have to check which is the shortest path among these paths to reach to visit exactly once without coming back to the same city, right? So once we started from city A, we have to visit all other three cities, that is B, C and D exactly once, and come back to the where we started, from which city we have started, that is from which vertex we have started, that is A. So initially we are considering we are traveling A to B, then B to C, then C to D, then again D to A. This is one possible way. And another way is A to B, then B to D, then D to C, then C to A. This is another way, another path. Then we have another path is A to C, then C to B, then B to D, then D to A. This is another one. Again, these are the possibilities, possible ways to travel, possible paths to travel all the cities exactly once. So A to C we can travel, C to D we can travel, then D to B, then B to A, and A to D directly, then D to B we can travel, B to C we can travel, C to A we can travel, then A to D, then D to C, then C to B, then B to A. These all are the possible ways, possible permutations we can uh, get here by seeing this graph, which by seeing this graph we can get these all are the paths. So in these we need to identify which is the optimal solution, because optimal solution in the sense to travel all those cities we need to, it should cost us less. So that kind of solution, that kind of shortest path we need to find. So consider only when b precedes c, 1 by 2 and minus 1 permutations we can get. So here very first the very first path gives us the 18 as the distance, 18 as the cost for traveling all the cities exactly once. That is A to B is 2, then B to C is 8, then C to D is 1, then D to A is 7. That is total the cost will become 18. Then the next path will give us 11, then 23, then 11, then 23 and 18. So among these 18, among these 11 is the shortest, 11 is the least, that is the optimal. Similarly, we have another one that also cost us 11. That is also an optimal. Either one we can select and we can travel all the cities exactly once and come back to the original city. So this is how the traveling salesman problem uh, we can solve with the help of exhaustive search. So let us summarize what we discussed so far. We discussed exhaustive search. What is we learned, we understood what is exhaustive search, and how the traveling salesman problem can be solved with the help of exhaustive search algorithm. So thanks for watching. If you are having any doubts in this, please do ask your queries. Thank you.